Hi everyone. Today I want to talk about imaginary numbers and complex numbers and some operations. Might be a long video. So the question is, what is an imaginary number? Well, I certainly can go right to the definition, but context here is really important. Here on my left, which is my left, right? For you, this is my right hand. Whatever. I have a quadratic function. The equation of this quadratic function is x squared minus 4 equals 0. We can tell that it is minus 4 because if the parent function started at 0, 0, I went down 4 units where my vertex is here. Now, this function has two answers for x. Now, when we try to solve quadratic functions, if you remember from Algebra 1, what I'm trying to do is I'm trying to find the x-intercepts of this function. Well, doing a little bit of arithmetic, if I add 4 to both sides, I'm going to get x squared equals 4. When I have a square, I have to square root both sides. This is going to give me x equals plus or minus 2. So there are two intercepts or two answers to this quadratic function. Positive 2, which you see, and negative 2. The teal graph clearly crosses the x-axis at these 2 points. But take a look at the graph on my right, which is my right, as I'm trying to stall so I can get a better marker. The equation to this function is very similar to the first one, but this one is x squared plus 4 equals 0. I know I should have went with the yellow marker first. Doing some arithmetic here, trying to solve for x, if I subtract 4 on both sides, I'm going to get x squared equals negative 4. And then I'll square root both sides. And then I have a problem. Because I don't know if you're aware of this, but your calculator, regardless of the calculator, it doesn't like to do square roots of negative numbers. And that makes sense, because a square root sign is kind of like saying, what number can I multiply by itself to get the number under the radical? Well, I don't know about you, but the rules of multiplication don't allow me to get a negative result when I multiply any numbers together. Not if they're positive together, not if they're negative together. So we have a problem. Now, furthermore, to help us with our point of imaginary numbers, two clear intercepts, two clear solutions. This function, however, is way above the x-axis. It never crosses that axis. So it doesn't have any real solutions. But here's the real kicker. I have a variable here and an equation. There needs to be a solution. That's where imaginary numbers come in. Let's keep going. Here we go. An imaginary number is when we have the square root of a negative number. Now, this is the most basic definition of an imaginary number there is because we have the most basic number underneath the radical sign. The square root of negative 1 translates to I. Yes, that is an I. And yes, that is a number. It's got to be a cursive I, so we can determine between, I of the alphabet and I of the number. This is the imaginary number. Now, clearly, on our last problem, for example, that wouldn't have been a negative 1 under the radical sign. It would have been a negative 4. Doesn't really change anything except for that would become a positive or negative 2i. Now, I is, again, the notation we use for imaginary numbers. Imaginary numbers exist just like the real number system does. So there's the real number system world, which is every number in existence that we are aware of, and the counting numbers all the way for whatever. And then there's the imaginary number system, which is I, 2i, 3i, 2.5i, 5 over 2i, negative 3i, negative 10i, and so on and so forth. Those are imaginary numbers because it's I and anything that is attached to the I as one term. Those are imaginary numbers. Now, again, we have our notation of the square root of negative 1, which equals I. But a complex number is a little bit different. A complex number is basically a composite, meaning a mixture of both the imaginary part, or an imaginary number, and a real number. Usually, they are matched together through operations. And the form that it takes is a plus bi, where a is the real part of that expression, and bi represents the imaginary part. We always want to leave answers when we're doing operations with imaginary numbers in this form. A, which is the real form, and bi, which is the imaginary form. Now, there could be a minus sign there. It doesn't matter so much either way. Just means that we have the real number or the real part first. Let's keep going. Now, at least we have a good basic understanding of what an imaginary number is and what a complex number is. The next part of this video is where we're going to use operations to simplify these things. And yes, we're going to simplify them just like we would normally. Think of I as a variable, like x. We're just going to combine like terms until we really can't combine like terms anymore, and that only happens when we get to multiplication, which is going to be coming up soon, as in this video soon. So we'll combine like terms. Let's take example 1. Relatively simple. I've got two imaginary numbers. I've got 4i plus 8i. Well, if you take I and pretend it's x, or pretend it's a variable, I've got 12i, and that's my answer. Not bad. Example 2. A little bit more complex, but we're still going to be adding together two expressions. Because there's a plus sign in the middle, we know that the parentheses just drop, and we combine like terms. So I've got a 6 plus 8, which is 14, and a 2i plus a 3i, which is 5i. And that's going to be our final answer, because it's already in the form a plus bi. So I'm good to go there. Example 3 says, negative 5i plus 1 minus 9i minus 6. Well, as opposed to the first two examples, on this one, I'm subtracting those two expressions. What we want to do here is we have to distribute the negative sign to both terms on the right. Plus signs don't distribute, ever. But minus signs always have to distribute. So that minus sign is going to distribute to the 9i and the negative 6. So once we distribute, we drop all the parentheses, then we combine like terms. So we have negative 5i plus 1 minus 9i plus 6. Let's combine like terms. Negative 5i and negative 9i is negative 14i. And positive 1 and positive 6 is positive 7. Now this isn't in the correct form of a plus bi, so let's just switch it around. This is going to be 7 minus 14i. Done deal. Let's keep going. So we've gotten to the more difficult part of the video, which I don't think is that difficult, to be honest with you. Multiplying can be a little tricky, and for one reason only. I guess I didn't realize how big I made that. I thought it was way smaller. I was actually genuinely surprised for a second. The problem when we multiply I to I, or I and I times I is I squared. That makes sense, because when we multiply a variable times a variable, we get that variable squared. That's fine. But the extra part here is where things get a little messy. I squared turns into negative 1. Now, there's a reason for that, and that reason is that first or second slide that we talked about. Because of our relationship of I and radical signs, we know that the square root of negative 1 is I. Well, if I were to square root both sides on this part, square rooting the I squared and square rooting negative 1, you see where I'm going, right? The square root of I squared is I, and the square root of negative 1 is the square root of negative 1. So there's this relationship here, where if an imaginary number is the square root of negative 1, that means if I were to square both sides, I would get I squared equals negative 1. So there's that relationship for us. If that was a little confusing, which it can be, think about it like this. Just know that whenever you have to square I, our answer is actually negative 1. So let's try a couple of examples together. Example 1. We've got the quantity 2i minus 4 and the quantity 3i plus 1. We are multiplying these things. Now we could do this a couple different ways. We could do FOIL, which isn't really what we do anymore when we talk about multiplying binomials. We could simply distribute and multiply. We could use the area model too. Let's go with the area model because we should be very familiar with it. So when I have an area model, I'm just going to draw my boxes like I normally would. Now this is kind of like a reverse area model. When we factored quadratics, we filled in some boxes and figured out some factors. But when we have actual factors already written for us, we're going to put them in the top and sides like we normally would, just the reverse. So let's say we have a 2i here, and a negative 4. Then on the side, I'll put 3i, and I'll put a positive 1. Now I'm going to multiply them like I normally would. 3i times 2i. Well, 3 times 2 is 6. I'll put the I squared, and we'll see where we go from there. 3i times negative 4 is negative 12i. 2i times 1 is 2i. And 1 times negative 4 is negative 4. Okay. Now, I can't leave this box as it is, because I squared is what? Negative 1. So what I'm actually going to do here is I'm going to erase this I squared, put a multiplication sign, and put negative 1. Because 6i squared said 6 times I squared. Now it's just 6 times negative 1. Let's wrap this up and finish the video. Now I've got a value that is negative 6 minus 12i plus 2i minus 4. I'm going to combine like terms. I'm going to end up with only 2 terms in this expression once it's multiplied, which you should get. Negative 6 minus 4 is negative 10. Negative 12i plus 2i is negative 10i. It's in the form a plus or minus bi, and we're done there. Why don't you try one on your own? You can go ahead and pause me, and I'll be back in a second. All right, let's see what we got going on here. I'll draw my trusty square area model. 7i minus 1, 8i plus 5. 8i and 7i. Well, we know that's going to be 56 when I multiply the numbers together. And I squared is going to be a negative 1. So this box in general is going to be a negative 56 here. 8i and negative 1 is negative 8i. 7i and 5 is 35i. And negative 1 and 5 is negative 5. Combining like terms all together, save a little bit of time. Negative 56 and negative 5 is negative 61. And negative 8i plus 35i is going to be 27i. Final answer, and it's in the form of a plus bi. Let's finish up. Things to remember about this video. Number 1, imaginary numbers and complex numbers are not exactly the same thing. An imaginary number is just one term, one thing. I, 2i, negative 5i, whatever. But a complex number is the composition of an imaginary part and a real part. Number 2, operations with complex numbers are just like handling with variables. We're going to combine like terms and utilize what we know of just basic operations and basic arithmetic. Add the things that are supposed to go together. Don't add the things that aren't. And then number 3, this is a huge idea. The square root of negative 1 is I. So whenever your calculator gives you the error sign when you try to square root a negative number, now you know what it means. See you next time.